How to land an airplane. In this scenario, you are a passenger on a Boeing 737-800, one of the most common passenger aircraft. What could you do if neither of the pilots were able to land it? We will be using Explain 12, a plane simulator, as our training tool. Step 1. Opening the cockpit door. The cockpit door is an impenetrable barrier. If it's closed, your only option is to use the emergency access panel. You can request the door to open, either with or without the secret code. The flight deck door selector inside the cockpit manages these requests. If no response is given and the code is used, the door will automatically unlock, granting you access. Step 2. Aviate, keeping the plane airborne. Welcome to the cockpit. Take a seat. If the autopilot is active, do not disengage it by pressing any unfamiliar buttons. You can verify its proper engagement by checking the display. Look for elements aligned with purple lines and green lights on the autopilot buttons. Monitor the autopilot and take manual control if it malfunctions. Communicate with ATC via radio. Prepare the flaps, landing gear, and auto brake, which will be explained later. If you need to take control, do the following. Press the left button on the yoke to disable autopilot navigation. Press the button on the throttle to disengage the auto-throttle. Lastly, press the autopilot disconnect button. You can turn off the autopilot off alarm by pressing this button. This is the yoke. If you push the yoke, the plane's nose will tilt down. If you pull the yoke, the plane's nose will tilt up. Moving the yoke sideways will tilt the plane sideways. Moving the yoke sideways moves the ailerons. Pushing or pulling the yoke moves the plane's elevator. Now, let's cover some basics of flying. Gravity constantly pulls the plane downwards. Air resistance, or drag, slows the plane, while the thrust from the jet engines increases its speed. With enough speed, the wings generate lift, which counteracts gravity and keeps the plane in the air. The plane's speed must be high enough for the wings to generate lift, but not so high that air forces become dangerous for the aircraft. Speed and altitude are both forms of energy. You can trade one for the other. To reduce both, you need to increase drag and decrease thrust. A common mistake is entering a stall, which occurs when the aircraft's speed, combined with a high pitch angle, fails to generate enough lift. A high pitch increases drag, significantly reducing speed. Even if you keep pulling the yoke, the plane will eventually pitch nose down toward the ground, and without sufficient altitude, this can be fatal. To avoid a stall, increase thrust and raise the nose 10 to 15 degrees above the horizon. Let's simulate a stall with the yoke pulled back continuously. You'll notice that the plane rapidly loses speed until it can no longer generate lift and begins to fall nose down. Sufficient altitude is necessary to regain speed and lift. Otherwise, the aircraft will descend to the ground. These are the throttle levers, which control the speed of the jet engines and, consequently, the thrust. Thrust increases a few seconds after the levers are pushed forward. When pulled back to idle, the levers can also be moved to provide reverse thrust. This alters the airflow through the engines, helping to slow the aircraft. Reverse thrust should only be used during landing. Engine status can be monitored on a central display, which shows the percentage of thrust being applied, exhaust temperature, and any warnings or errors. The display also indicates the remaining fuel in pounds and specifies which tanks contain the fuel. This is the primary display. It indicates the plane's position relative to the artificial horizon, with the sky shown in blue and the ground in brown. The aircraft's speed is indicated in knots. The altimeter displays the altitude in feet above sea level. Finally, a compass indicates the direction of travel. Let's see all of this in action. The artificial horizon shifts as we move the yoke sideways. Pushing the yoke downward decreases our altitude and increases our speed. Finally, we stop the descent by leveling off with the horizon. This is the speed brakes lever, fully extended and now retracted. It controls surfaces on the aircraft that increase drag to reduce the plane's speed. This is the flap lever, which alters the wing's shape to enable flight at both lower and higher speeds. We are currently lowering the flaps. With high flaps, the wings generate increased drag, allowing the plane to fly at slower speeds. Flying at high speeds with maximum flaps can risk damaging the aircraft. In contrast, low flaps reduce drag, enabling faster speeds, but failing to provide adequate lift at low speeds. The lever controls both the flaps and slats simultaneously. Quick instructions for cabin depressurization. To set cabin pressure automatically, turn this knob to the auto setting. Quickly put on the mask located beside you and initiate a descent to 6,000 feet, where the air is breathable. The passenger masks will deploy automatically. Step 3. Navigate. Heading to a nearby airport. Set this knob to the map setting to adjust the display below. The knob to the right controls the distance in nautical miles. Press the ARPT button to view blue dots on the display, representing nearby airports. Now we'll observe how turning the airplane adjusts the display, similar to navigating on a phone map, so that the destination airport is aligned in front of the aircraft. Step 4. Communicate. The transponder sends an identification code to air traffic control. We will set it to 7700, the general emergency code. Next, set this knob to alt on to transmit our altitude. Finally, press the ident button to alert air traffic control. This is the radio. Turn these knobs to set the frequency 121.5, the emergency frequency. Press the double arrow button to set the frequency to active. Press the leftmost button to speak. Flip the indicated switch to a T to talk. Step 5. Prepare for landing. To safely reduce speed and altitude, level with the horizon, lower the throttle, and gradually extend the flaps. Avoid extending the flaps too much, as entering the higher red zone signals a dangerous speed. The lower red zone indicates the minimum safe speed. At 120 knots with full flaps, tilt the nose down for a slow descent to 4,000 feet. Hold this altitude until the airport is in sight. If you need to abort the landing during descent, throttle up to maximum and raise the nose about 12 degrees above the horizon. Maximum throttle should only be used safely for a few minutes at a time. Set the auto brake knob to the max setting, which will engage during landing. Avoid tilting the rudder pedals near your feet, as this will activate the manual brakes and override the auto brake system. This lever deploys the landing gear. Move it down to extend the gear, which will slightly increase drag. You can push either rudder pedal to move the rudder, which is used to align the aircraft with the runway. However, only use it at lower speeds. Pushing either rudder pedal also controls the steering of the front wheel. This is a taxiway. Do not land here. This is the runway, where you should land. The touchdown zone is marked with clear indicators to guide your landing, ensuring you don't touch down too early or overshoot. The aiming point is indicated by two thick white lines. You'll see the runway from this perspective. This marks the start of the runway, and this area is the touchdown zone. Here are the runway lights, which indicate whether your current slope is to high or to low based on the number of white and red lights. In this example, you have 4 white lights, indicating that you need to descend further. Lastly, this switch will signal to the passengers to fasten their seatbelts. Step 6. Landing. We're in the final moments of our approach. You are on a slope aligned with the start of the runway. The 4 white lights indicate that you are too high, so we will need to descend further. These yellow wings indicate the angle for a stall. We have the altitudes displayed. The radar altitude is more precise, as it reflects the actual distance from the ground. We're maintaining a speed of 120 knots, which is below the red bars and sufficient for flight. We are experiencing a slight vertical descent, which we will reduce as we approach the ground. Increase throttle if you're near the lower red markings and getting too close to the ground. In this case, it's not necessary. When we see to red and to white lights and have 300 feet remaining, we will shift our aim to the thick white lines of the aiming zone. As we approach the ground, gently tilt the nose upwards to avoid landing on the front wheel. Gradually lower the nose after touchdown. While doing so, engage reverse thrust to quickly reduce speed. We will then steer the aircraft using the front wheel with the rudder pedals. As we near a complete stop, return the throttle to idle and engage the parking brake. Congratulations, you have now learned how to land a passenger aircraft. Hopefully, you'll never need to use this knowledge.